Okay, we're back on this puzzle. It's called Semi-Symmetry. It's a very hard puzzle by Lizzie01. We're refreshed. We're hopefully ready to go. And there's going to be a link in the video for the part one, where I struggled with a lot of things and I came up with some decent restrictions, but we're still a little bit off. So hopefully we can get this solved today. And um, yeah, let's get to it. Okay, so what I had before was, yeah, we know a 4 has to be in one of the corners. So there's a limitation that we know the red squares add up to 43 at least. And, right, because it's 6 plus 6, which is 12, plus 15 plus 15, which is 30. So 30 plus 12 is 42, and then we have an additional 1, so that's 43. The 4 has to make one of the 5s essentially a 1, 2, 3, 5, 6. So it jumps from 4 to 6. So therefore, that's two degrees of freedom that are taken away. So that leaves 3 degrees of freedom. We also found out that 7, 8, and 9 cannot be both of these. So we're limited there too. What else did we learn? So one of these has to be 5 or 6, right? One of these has to be 5 or 6. Can it be 5 and... No, it can't... Well, maybe it could be 5 and... No, it can't be 5 and 6. Because that would mean the 7's going down to a 5, and 8 is going down to a 6. That's 4 degrees of freedom that we lose from that. And we already know that we've lost 2 degrees of freedom from our 5 previously, so we have 3 degrees of freedom left. So there cannot be both 5 and 6 in the same column in the circles, but there could be a 5 and a 6 in the same, in both of them, and then you have 8 and 9 left over, right? Oh, yeah, how does that work? So say you did have a 5 or 6 here. If you had a 5 and a 6 here, that means one of these is 5 or 6, one of these is 7, 8, or 9. But the problem is that you just lost 3 degrees of freedom there. And since you lost 3 degrees of freedom there, that means that's all the degrees of freedom. So therefore, this has to be 8 and 9 and 8 and 9, right? Because the 7 goes down to a 5, and then the 7 goes down to a 6. But the problem is, you need an 8, 9, 8, 9, and then this also goes away to 8 and 9, 8 and 9. But then you have, where's the 8, 9 in box 4, 5? It can't be anywhere, right? Because the 8 and 9 is taken care of, the 8 and 9 is taken care of. So you cannot have 5 and 6 in the middle circles. Because you then that forces an 8, 9, 8, 9 elsewhere, right? You cannot have 8 and 9 on both. Therefore, you can't have 5 and 6 on both of these circles here. Because that takes away all our degrees of freedom, because this becomes 8, 9, 8, 9, 8, 9, 8, 9, which means none of these can be 8 and 9. Therefore, what happens if 6 is in one of these? That means 4 has to be in one of them, so the 4 has to jump to a 6. That's 2 degrees of freedom lost. The 5 also is in one of them, so either the 5 goes to a 6, which means we lose a degree of freedom, and we already lost a degree of freedom with the 6. But that seems to be okay. The 4 and the 5 both cannot be together, right? Because if it's 4 and 5 together, that means you would have to have 1, 2, 3, 6, 7, and you lose 4 and yeah, so the 4 has to be separate from the 5. Therefore, the 5 can go to a 6 in degrees of freedom. And on top of that, so the 6, so we lose the 5, the 4 goes to the 6. Ah, I'm starting to see it. So basically the 9, where is the 9? Well, no, the 9 could be one of these two. Does the 9 have to be in one of these circles, is the question, right? If it isn't, that means the 9 must be one of the corners. Which means one of these cannot be 9. It would have to be 6, 7, and 8. So if the 9 is not in one of the center circles, then the 9 has to be in one of the corners. And if the 9 is in one of the corners, that means it's eliminating all 3 degrees of freedom from the circles, essentially. So by doing that, we no longer have all the degrees of freedom. So if there is no 9 in the center, the 9 has to be in one of the corners, and therefore eliminates, drops the 9 from being in the 48 for the numbers down to 6, 7, 8, which is 21. So we lose 3 degrees of freedom. In addition to that, we know 5 and 6 cannot be both the numbers because we tried that, right? If this is 5 and 6, this is 5 and 6. This therefore becomes 8, 9, 8, 9, 8, 9, 8, 9, which eliminates 8 and 9 here. Therefore, if 9 is not one of these two central numbers, that means that we lose 3 degrees of freedom because one of the 9s has to be in the corners and not be in a circle. So that eliminates 7, 8, and 9 as a possibility. It makes 6, 7, 8 the highest possibility. But one of 5 or I guess it could be 6, right? So if you go 5 and 9, or not 5 and 9, but like 5 and 8. Well, you can't have 5 anymore. So you have to have like one of 6 and one of 8. And therefore 5, aha. So therefore 5 would have to be in one of the corners too. And the 4 already has to go to a 6. The 5 also has to go either to a 6 or a 7. So you lose at least 1 degree of freedom. Therefore, the 9 cannot be in one of the one of the corner cells in box 5. Does that make sense? I hope that makes sense. Because basically, the 9 can only be essentially, like, if we assume that the 9 is not in one of the circles, the 9 has to be in one of the surrounding corner cells. And if it is in one of the surrounding corner cells, that means it's eliminating a 7, 8, 9 possibility for one of the circles. And because of that, that drops 3 degrees of freedom. And we already lost 2 degrees of freedom from the 4, having to go up to the 6. So if the 5 has to go up to a 6, that means we've also lose 1 more degree of freedom, which means 6 degrees of freedoms that we lost when we only had 5 available. So the 9 has to be in one of the circles. That's actually very clever. This is actually a very interesting puzzle of the way it interacts. What about 8? Can 8 be outside of these two. If you have 8 outside one of those two, that means you lose 2 degrees of freedom to a 6. So it'd be 6, 7, 9 as one side, and then 7, 8, 9 as the other side. If you lose, so 6, 7, 9, so that would add up to 22. And then 7, 8, and 9, which would add up to 24. So it's 46. We've already lost 2 degrees of freedom from the 4 to the 6. The 5 would have to be 1. So it's possible that the 8 is not one of those. So we know 9 cannot be here. 9 cannot be here. 9 can never be on an arrow. Therefore, we know 9 is one of these two, and 9 is one of those two. Therefore, this can't be 9. So this can be at most 8. So 3 through 8. Which means this is 7 at most. I don't know if that tells us anything else. One of them's 9. How many degrees of freedom do we lose when we have an 8? We have the 8. That means we lose 2 degrees of freedom. So it drops to a 6, 7, 9 and a 7, 8, 9. Oh, this can't be 5. If either of these are 5, so say this was 5 and this is 9, therefore. We know 8 has to be one of these two, right? The 5 loses us 2 degrees of freedom. I guess 8 could drop to a 5, and then that actually does work. The 5 could, yeah, that could still work, actually. Yeah, I think what we also proved in the previous video, we know 1 and 9 does not work, right? Then that becomes 9. This is not 1. This can't be 9, so therefore this is 8 at most. And then we know this is at minimum 8, so this has to be 8, which means this is 1. This can't be 1. This can't be 1. Therefore, this could be 2, 3, and 2. Right? So this could be 7 or 8. This can't be 8 or 9. This is 1. This has to be either 2, 6 or 3, 5. This has to be 1 and 2. This cannot be 2 and 3. So this is 2, this has to be 3 then, which forces this to be 8, right? And that doesn't work. So that's the reason why it can't be 1 and 9. But what about just regular 9? I think that does work as a possibility, right? It just can't be 1 and 9. So technically the 9 could go down to a 6 in one of the circles. And you could have 6, 7, 8 in one side and 7, 8, 9 on the other side. Oh. One No. Yes. Okay, so you cannot. Showed you can't have 7, 8, 7, 8, 9, 7, 8, 9, 7, 8, 9. You can't have three of the same digit in both of the circle, in all the circles, right? In both columns of circles. Because if you have 7, 8, 9, 7, 8, 9, 7, 8, 9, and 7, 8, 9, 7, 8, 9, 7, 8, 9, where is the. That eliminates 7 and 8 from 7, 8, and 9 from all of these circles. All of these corner squares in box 4. It's 5, sorry. Which means that this becomes 4, 5, 6, 4, 5, 6, 4, 5, 6, 4, 5, 6 in 4 cells, which is impossible. That's why you can't have 7, 8, and 9. Oh, so if you have 6, 7, and 8 in one, in 7, 8, and 9 in the other, well, we just showed you can't have 9 in one of the corner cells. Because then you do have to have 6, 7, 8 in one side. And that's all 3 degrees of freedom lost. In addition to the 2 degrees of freedom you lose from the 4, 6, the 5 also eliminates 1 degree of freedom, at least. So the 9 has to be there, which means the 9 has to be repeated. The 8 or the 7 has to be repeated. Because you cannot have, say you did have, in one column it was 6, 7, 8, in the other column it's 7, 8, and 9. That doesn't work. Because the problem is that you now have to have, you have to have the 7 and 8. Where are the 7 8 in box 5, if that's the case? We know 9 has to be one of these two. And then the 7, the 8 has to be, one of them could be in the other circle, but then one has to be in the corner, which means it eliminates the possibility of a 6, 7, 8 or a 7, 8, 9 in one of the columns. Therefore, you have to have both of the numbers that are basically in both columns. So, okay, so if you have 5, 8, 9 and 6, 8, 9 as essentially the columns, 8 and 9 in box 5 have to be in the circles. Because there's no other like, otherwise, if it's not, where does one of them have to be in box 5? It has to be on one of the corners, which eliminates the possibility of 5, 8, 9 or 6, 8, 9 in the columns. Therefore, 8 and 9 would have to be in the middle if it's 5, 8, 9 and 6, 8, 9. And I think you have to have two of the same numbers. You cannot have 5, 8, 9 and 6, 7, 9 because that only adds up to 44. And we've already lost 2 degrees of freedom already from 43. So the 43 would basically have to be up to 45. So therefore, we know then, yeah, you can't have 5, 8, 9 and 6, 7, 9 because those are the lowest two that you could possibly have where you have overlap. And you have to have a 9. So you have to have a 9 in one of the things. So it has to be double. The 9 has to be doubled in both. Okay, so actually that's a good point. The 9 has to be doubled in both columns, but column 4 and column 6, because otherwise it's not gonna work, right? Because then if you don't have a 9 in here, that means either the one of 7 or 8, or 2 out of 7, 6, 7, or 8 has to be doubled, which doesn't work, right? So that actually it has to be 7 and 8 that are doubled if the 9 is not doubled. And then therefore one of them is outside of the circles, so therefore it eliminates its so if you had an 8 it's outside the circles in box 5, it would eliminate an 8 in its column. And so therefore you would lose all the degrees of freedom possible. Actually, you would lose more than the degrees of freedom that you already have. So you don't have that available if that's the case. Because you would have to have only one 9, so it would be 7, 8, 9, and 6, 7, 8, because you have 3 degrees of freedom left. And then on top of that, the 8 gets eliminated for one of them, so that's not possible. So the two circles must contain the digits that are in both of the actual columns in the circles, right? So the possibilities are you could have 589, 689. That's possible. And that would work for degrees of freedom. But the problem, the 8 and 9 would have to be here, right? We know the 9 has to be here. So 589, 689 works. 589, 789 also works. Right? 589, 689 works. That's all the degrees of freedom you lose. So those are already taken out. 589, 789 means there's a 4 and a 6 in the corner. But that's still 8989. So yeah, that seems fine. Can you ever have a 7 with it? So okay, so this can never be 5 or 6 essentially. Because of this, we lose another degree of freedom because the 5 has to be in one of these corners, right? It could lose 2, but we have to lose 1, right? Because the 4 already goes to a 6. So you have 1, 2, 3, 5, and 6 is the minimum of one of the set of 5. Then the 5 has to go to the other side to make it a minimum, right? So then it would be 1, 2, 3, 4, 6 as the minimum on one of the sets of 5. So therefore, we've lost 3 degrees of freedom now. The 6... Oh, wait, no, the 6 also... Can 6 be duplicated? 6, 7, 8, and 6... 8, 9. No. 6 can never be duplicated, so it has to be 7 and 8. So we lose... We've lost 4 degrees of freedom here. The 4, 5, and 6 have to be in the corners. If you have 4 going to... Right, you could have a 4 jumping to a 6. But if you have 5 and 6 on the... So if you have you have to have a 6 in one of the corners. You have to have a 5 in one of the corners. So 5 gets eliminated in either the... Yeah. So say you had... Okay, so say you had 4, 5 here in this row. If you had 4, 5 here, that means the lowest it can be is 1, 2, 3, 6, 7. So since the lowest you can have is 1, 2, 3, 6, 7, you've lost... The minimum now becomes 1, 2, 3, 6, 7. That's 19. Yeah, 6 plus 6 plus 7 is 19. So then you have 19. The 6 could be on the other side. Then this would be 15. So 19 plus 15 plus 1. 19 plus 15 plus 1 is 45. No, 35. And then you have 6 and 6. So that's 12. That's 47. So we've lost 4 degrees of freedom there. Now, if you have 4 and 6 on this side and 5 on the other side, that means that you have the minimum 1, 2, 3, 5, 7 on one side, and you have 5, so 1, 2, 3, 4, 6 on the other side. So 1, 2, 3, 5, and 7 should be 18. Yes, it's 18. And then 1, 2, 3, 4, 6 is 14, so that's 34 again. So the first one you had 1, 2, 3, 6, 7, which is 19, plus 1, 2, 3, 4, 5, which is 14, which is 34. Same thing here. If you have 4 and 6 on the same side, so that was 4 and 5 on the same side. What if you have 4 and 6 on the same row? Then you have 5 on the other side. Then it's 1, 2, 3, 5, and 7, which adds up to 18. And then the other row has to be 1, 2, 3, 4, 6, because the 5 is here. And that's a minimum of 16. So 16 plus 18 is 34. So you again lose the same 4 degrees of freedom. And in addition, then you also have, if you have 5 and 6 in one row and 4 in the other row, that means 5 and 6 so it has to be 1, 2, 3, 4, 7 is the minimum, which is 17. And the other side has to be 1, 2, 3, 5, 6, which is 17. So 17 plus 17. So either way, all scenarios, you lose 4 degrees of freedom. Therefore, you have to have a you have to have a 9, and the 7 goes down to an 6 once. So therefore, you know this is 8 and 9. So you know this is 8 and 9. So this can never be 8 either. You can never have an 8 in one of these because you've lost all degrees of freedom there. Therefore, one of these is 6 and 9, and one of these is 7 and 9. So this cannot be 5. One of these is a 6, and one of these is a 7. So one of these is a 6, and one of these is a 7. This cannot be 8. This cannot be 8. So because we know that, this has to be an 8 and 9 pair. Right? Where else can the 8 be here? Right? Because either you're losing 4 and 6, in which case you have the minimum, yeah. Right? It cannot have essentially a 1-8 in one of these. Because if there was a 1-8, you lost essentially, the 4 would have to essentially go to an 8. That's 4 degrees of freedom you already lost. And then the other side isn't taken care of. Right? So say you had 4 here. So the 4 goes, actually no, say you had a 5 here. The 5 goes to an 8. That's 3 degrees of freedom lost. You would have to have the 4 on the other side, and that's 2 degrees of freedom lost. But then you have, so the 5 would be here, the 4 would be here. That means the 4 goes to a 6, but then you have to have a 6 in one of these. 1, 2, I guess, maybe, actually, hold on. Is that actually the case? We do know that the 8 and 9 have to be in that spot. So this has to be 8 and 9. This can no longer be 5. This can't be 8. This can't be 8. Can this ever be 1-8? If this is 1-8, this has to be 9, which makes this 8. We lose the 1 here. We lose the 1 here. This can't be 9. This can't be 9. So 1 of 2 or 3's here. This can't be 8. This can't be 8. This can't be 1. So let's say that the 5 was here. So this can no longer be 5. But we could have 4 with 2 or 3, right? So then this is 6 at most. This would be 4. We've lost 3 degrees of freedom here. From the 5 to an 8. This could be 4 over here. Which means that means we lose the 4 to a 6. So this becomes 1, 2, 3, 5, 6. This is obviously 4. This can't be. So therefore this can't be 4. This could be 5. This can't be 5. The 4 becomes a 6, so therefore this can't be 6. This could be 7. So it's 5, 6, 5, 6. This becomes a 7 or 9. This is a 7 or 9. So this is possible, I think. This cannot be a 1. Ah, well then, no, that could be 1. So this is 2, 6, and 3, 5. This is 2, 6, and 3, 5, which which is contradiction because this has to be 8 at least, and then this has to be at least 1, and therefore that would have to be 9. And I think you run into the same problem the other side, right? Right. So therefore, yeah, if you have a 1, 2, 3, 5, 6, right? So this was 1 and 8, and I think it works both ways, right? If the 1 and 8 is here, it could be 5 and 6 here, and 4 and 7 in the other one. But then what happens is that the 9 forces this not to be 9. But the problem is, it has to be 8 and 8 on both sides. And therefore, one of these would have to be 9. Right? Huh, that's actually interesting then. What scenarios are there that allow this to actually function, right? Once you have a 9 here, or a 9 here, if you have a 9, we know 8 and 9 are here, right? So therefore, okay, so then we tried 1, 8, 1, 8 doesn't work. Therefore, this has to be an 8, 9, 8, 9 pair, which is interesting, right? This has to be 8 and 9, this has to be 8 and 9, because 8 and 9 cannot be here, 8 and 9 cannot be here, 8 and 9 cannot be here. So this is 8 and 9, this is 8 and 9. This can't be 8. So this is 8 or 9. What happens when this becomes 9, right? If we've already lost 4 degrees of freedom, we know the last degree of freedom is taken up by 6, 7, 8, and 9 in one of box 2 or box 8. Um, can this ever be 6 is the question. Maybe? Hmm. One of these has to be 7. Hmm. Hmm. One of them has to be 7, and I think the other one has to be 6, right? If it's not, you can't. I guess you could be 1, 2, 3, 6, 7, right? Hmm. Okay, what's the minimum you can have in each row in each of these places? Actually, what's the maximum you can have? Obviously, 1, 2, 3, 6, 7 is the max. So that's 19. That means the other side has to be 15? Hmm. Which means that, okay, so one is 19. Okay. So say you had 1, 2, 3, 6, 7 in one of these rows, right? You could have the 3 here, and you would have to have 1, 7, and 2, 6. Or 2, 7, and 1, 6. And I don't think that would work. You can't have... Okay, so say this was 2, 7 here, right? Say this is 2, 7. This then becomes a 9. This is an 8. This has to be 1 and 6 at least. So therefore, this is, I mean, well, you could have a 1, 5 or a 1, 4, but we're just saying you have a 4, 5, 4, 5 pair there. Then this has to be a 3. This has to be at least a 1. I guess it could be 2. And therefore, that would have to be 9. Okay, so that kind of works. So we've lost 4 degrees of freedom here. This can't be a 6 or a 2. It has to be 1 with something. This can't be 9 anymore. This has to be, can't be 1, 7 or 2, 6, so it has to be 3, 5. Which means this can't be 3 and 5, it's 1 and 4. So therefore, this has to be 2, and this would be 1. The question for me, I'm starting to think, is where can the 1, we've lost all our degrees of freedom. Actually, now we know. Yeah, we've lost all our degrees of freedom. This has to be a 1. We've lost all our degrees of freedom. The 4 has to, remember, because the 4, 5, 6, 7s are in the corners, they eliminate possibilities in the row of 5, right? That's 4 degrees of freedom. We've tried all the different routes. There's 4 degrees of freedom we lose. This can never be 7, 8, 9 in both of the columns in columns 4 and 6 with the circles. Therefore, one of them is 6, 8, 9, and the other one's 7, 8, 9, so we lose 1 degree of freedom, and that's all the degrees of freedom that we have. Therefore, we know the set of reds adds up to 47. The circles also add up to 47 that are in column 4 and 6. And we know that for certain. So the question is where everything else has to be, right? We know this has to be 34 here. This has to be 12 because it's, it has to be 12. So this is 1, 2, 3, this is 1, 2, 3, this is 1, 2, 3. Interesting. So this can't be 3, this can't be 3, which means this can't be 6. So yeah, we lost all our degrees of freedom there. So this is 34 in the 5 red cells in those 2 rows. So that's 34 plus we have 12 and 12, 6 and 6, which is 12. So 34 plus 12 is 46, and we have a 1. That's 47, and we know this has to be at maximum 47. So we know this now that this works. So therefore, this has to be a 1. Okay. Because this is 1, this can never be 9 anymore, right? Because this is at most 1, 3, 2. Okay, this could be 9. This can't be 9 anymore. Because this is at most 3 plus 2, 3. So this cannot be 9. This could be 1. It cannot be... Yeah, it could be... We've tried 6. It can't be 6. This can't be 9 anymore. So we know these two are 17, and therefore these must add up to 17. The red cells, right? Um, I guess another way we could have done it is that we know this has to be 1 through 7, and this has to be 1 through 7, right? So that means both of those sets of 7 cells have to add up to 1, 2, 3, 4, 5, 6, 7, which is 28 times 2, which is 56. We know we have 4, 5, 6, and 7 removed from it, which is 22. So 56 minus 22 means this is always 34. And that's how you look at it, I guess. Hmm. One of these has to, 3 have to be 6. We don't know which, though. Hmm. One of these two has to have a 7. Hmm. So this can never be 8 here, because if this is 8, this would have to be 9, and therefore that would not have a possibility. Um, hmm. Oh, interesting. Huh. Oh no, never mind. I was thinking something else. This is 17. This is 17 for these 4 squares, which means these 3 squares and these 3 squares. One of them is 7. Um, you have 17 in these 3 and these 3. Plus 6 plus 6. So that's 29. 29. Right, which would be 6 and 9 and 8 and 7 and 9. Does that really work? I don't think so. Hold up. 12 plus 17 is 29. Hmm. Oh, because you can't have, yeah. One of them can't be 9, one of them can't be 8. So it's 6 and 9. Does that work? 6 and 9 is 7 and 8, but that's 30. Oh, we forgot to add the 1. So we also have the 1. Right. So that's 30. Yeah, okay, that works. Hmm. This can no longer be 9. Ah, this can't be 1. If this is 1, therefore we know 1 is here. And it has to be 1, 8 to form an 8, 9, 8, 8. Okay. So say this was 1. If this is 1, where is the 1 in row 6? It can't be here anymore. It can't be here. Therefore, it has to be on this line. We know one of these adds up to 9. So therefore, either this is 1, 8 or this is 1, 8. But we showed previously 1, 8 is not possible. Therefore, we know 1 cannot be here. Therefore, we know 1 has to be in this one, which forces the 1 to be here. Right? We know also this, well, yes. So this adds up to at least 6. This adds up to at least 6. So this cannot be 1 and 2, because 1, 2, and I guess 1, 2, 3 does work. Never mind. We do know that this has to be 1 at least. This has to be 1. So therefore, one of these, so then if this is 2, one of these has to be 2. Okay, first of all, one of these has to be 7. We know that for certain. One of these has to be 7 because we know we don't have the 7 available for all the rows in both these, for all the cells in both these rows. So one of them has to be 7, which means it has to be with 2 because 1 can no longer be with it. So therefore, if this is 2 and 7, if this is 2 and 7, this has to be 3, which makes this at least 1 and 4. Right, and then this becomes 2. This can't be 2. This would have to be 8, and it would have to be 3 and 5. Ah, okay. I'm starting to see it. So 7s has to be in the other row as 5s. Because 3 and 5... 7 has to be with 2 to form a 9. And the other set cannot have a 2 and cannot have a 1. So it has to be 3, 5 to form an 8. So either this is 2, 7 and this is 8, 9, and this is 3, 5 and this is 8. Or it's the other way around, right? So either this is 2, 7 or 3, 5, or this is 2, 7 or 3, 5. So either way, this has to be one of 2 or 3, which means this cannot contain a 2 or 3. This cannot contain a 2 or 3. So we know the 1 is here. We know the 1 is here. One of them has to be 2, 7 and 3, 5. So this can never have... So either this is 3, 5 or this is 3, 5, which means this cannot have 3, 5, and this cannot have 3, 5. So one of 4 6s here, right? So one of these is 8 and 9, which has to work with 2, 7, and the other one has to be 8, which cannot have a 1, so it can't be 1, 7, can't have a 2 anymore, which is 2, 6, so it must have 3, 5. So therefore, it's 2, 3, 5, 7 here, which this is 2, 3, 5, 7. This is 1, 4, or 6. It still could be 6 here, though. So let's say this was 6. If this is 6, this can no longer be 6, which means this is 1 and 4. So this can't be 4. The 4 has to be here, which means this can't be 4. This is 1 and 6 at least. So this has to be 7 at least. No, this has to be 8. So this becomes 6, 7. Ah, and we have a contradiction. So, actually, no, we don't. This has to be 7 then. So this becomes 1, 6. This cannot be 3. So this is 1 or 2 with 1 or 6. This has to be 7. This can't be 7. This has to be 8 and 9. Which means the 3 has to be here, right? This is 7. It cannot be 1 and 2. Say it was 1 and 2, right? If this is 1 and 2, this would be at most 3. So this cannot be 1 and 2. It would have to be at least 1 and 3. Well, actually, we already know. This has to have a 3. This can't be 3. This is 1. So this becomes 2, 3, and this is 2. Which makes this 3 and 5, which makes that 8, which makes this 9. But that's a 1. So we have a contradiction here. Right. There we go. So this, interesting. So this cannot be 6. We just tried this being 6. So, and I think the others, well, no. It's because there's an extra 1 here, right? So say this was 6 again. This has, okay, so first of all, the 5s cannot be here. So say this was 6. If this is 6, that means this has to be 1, 4. This has to be 1. So therefore, this is 2 and 3. These can't be 4. Therefore, the 4 has to be here, which means this can't be 4. So this is at least 1, 6. So therefore, this is 8 or 9. This can't be 8 or 9. This has to be 7. So this is 2, 3, 2, 3. Therefore, this is 2. Therefore, this has to be 3 and 5 to make this an 8, which makes this a 9. This is now 2 and 7. So this is 3. But we have a 2, 3 here. And this can't be 2 or 3, it's 1, so therefore you have 8 plus 8, so therefore that's 8, which is a contradiction. Therefore, we know this can't be 6 here, so this has to be 7, which means these can't be 7, so we have a 4, 5, 7, 8, 9 triplet here. Therefore, this has to be 6, 8, and 9, so this cannot be 7, this can't be 7. So either this is 6, or this is 6. Now let's try this being 6. If this is 6, then this becomes 1 and 4. This has to be 1. So the 4 cannot be here. Okay, also, yeah. Also, we know these two can't be 6 because it has to be a 6, 8, and 9 triplet here. This can't be 6. So if this is 6, this has to be 1 and 4. This has to be 1. So these can't be 4. This can't be 1. This is 2 and 3. So this adds up to 5. And this is, so this can't be 7, 8. This has to be 7. But this can't be 6. So this can't be 4. This can't be 4. So this has to be 1 and 6. But we have a contradiction again, because this cannot be 7. Therefore, yeah, we've shown both the 6s cannot be in these cells. Therefore, this is a 6. So since this is 6, this can't be 6. Cannot be 6. This can't be 6. This can't be 6. We know 6 is here, and 6 has to be one of those. Okay, so orange is not... So these are not... These are fine. Can this be 7 is the question. If this is 7, it's the same thing. This has to be 1 and 4. This has to be 2 now, though. So now we have 1, 3, and this is 2. So this is, again, 3, 5. But then this becomes 8. So this seems kosher. This is 9, 2. This has to be 1, 6. And then this cannot be 3, 5. It's 2, 7, 3. Yeah, so this seems kosher. Um... Hmm. Hmm. Can this be 7 is the question. If this is 7, one of these is 3. We don't know which. If this is the 7... Oh, wait, we know exactly... Yeah, well, no we don't. No we don't. This is at least 6. And this is, yeah. We know the minimum. We don't know what the maximum is. Hmm. So I think 7 can actually be here right now, too. If this is 7... Oh, interesting. We know, okay, so this number... So let's remove the yellows. This number must be the same as this one, right? Because it's 8 and 9, and this one's the other 8 and 9, right? Actually, make this yellow. We'll make this yellow, and we'll make this pink. This yellow adds up with this yellow to have this and then this. Well, Can this be 8 is the question that I was thinking of, right? If it's 8, that means these 4 and this must add up to 16. We then know, okay, so if this is 8, this has to be 3, 5. This is 2. This is 9. This would have to be 3. This would be 2, 7. So the 7 could not be here, therefore this would be 7. The 5 cannot be here, therefore the 5 is here. So far this is looking fine. So this, okay, so this is 3, which makes this 1, 2. So therefore this would force this to be 3, which would mean this is 1, 4. So far this looks okay. This is 6, this cannot be 4. So this is 1, 6, which means this has to be 9, and this is 3. Ah, but then we have a contradiction, 1, 2, 1, 2, and this has to be 6. So no, it cannot be 8 here. Okay, interesting. That's interesting how it disambiguates there. So this has to be 9, which means this cannot be 3, 5. This can't be 2, so this is 3, this is 2, which makes this 1, 3, which makes this 2. This can't be 9, so this has to be 1 and 4. This can't be 2 and 7, it's 3 and 5. So the 4 cannot be here. So the 4 is in one of these two, which means this can't be 4. This is 1, 6. And therefore this is 2. So this is 1 and 3. This is 1 and 3 and 2. This is 3 and 5, which makes this 7 and 6. Which makes this 4 and 5, but we don't know which one's which. So this can't be 7. Yep. Interesting. So then this has to be 7. This has to be 8, which does fit. So it's 1, 3, 1, 3. So this can't be 8 or 9. Actually, we already knew that before. This has to be 8 or 9. So this can't be 7. This is 6 or 7. 4, 5. This can't be 9 anymore, which means this cannot be 4 or 5. So this is 5, 6, 7, 8. This has to be 3, 5, and 6. This has to be 2, 4, and 7. Now we have the other arrows, which we haven't even looked at because we were so busy trying to figure this middle portion out. This can't be 1, 7. It can't be 2, 7. It could be 1, 8. This is 3, 4, or 7. So it could be 1, 6. It could be 2, 5. Or 1, 2. Or 1, 3. It's basically 1 through 6. Hmm. Okay. Actually, let's just leave that one. So 9 cannot be here. 9 cannot be here. So 9 is one of these two. Okay. 8 cannot be here. 8 cannot be here. 8 can't be here. Ah. So 8 is one of these two. Which means 8 has to be along this. So either this is 8 or this is 1, 8, and therefore that's 9. Right? 8 can't be here. 8 can't be here because of this 8, 9. 8 can't be here because this is at most 8. So 8 has to be one of these two specifically. So if this is 8 and this is 9, this has to be 8. Otherwise, this is 8 and that's 9. So say this is not 8. Then we have 9 here. This has to be 1 and 8. 1 and 8, which makes this 6. So this can't be 8 or 9. So this is 9. This is 8. This cannot be 1, 7. It cannot be 2, 6. This has to be 3, 5. And we have a contradiction. Therefore, we know 8 has to be here. So we tried 8 being on one of these two arrows. It doesn't work. So therefore, this has to be 8. Which means this could be 1, 7. It cannot be 3, 5. Or it's 2, 6. So this is 1 or 6. Which means this can't be 1 or 6 here in the rest of column 8. So this can't be... Okay, so where's the 9? The 9 cannot be here, cannot be here, cannot be here. Therefore, this is a 9. Therefore, this can't be 9. This cannot have a 1 or 6. Still could be 2, 3. This cannot add up to 8. Because if this was 8, this would have to add up to with 1, 7, and 2, 6. But then we already have another 1, 6 here. So that would be 5 digits that must contain 1, 2, 6, and 7, which are only 4 digits. So therefore, this cannot be 8. This cannot be 8, therefore. Therefore, this is 8. This could be 2 and 3 if it's 5. In fact, it has to be 2 and 3 if it's 5. If it's 6, it cannot contain a 1, so it's 2 and 4. If it's 7, it cannot be 1, 6. It could be 2, 5, or 3, 4. So this would be 2, 5, or 3, 4. This can't be 2. So this is 9, which means these can't be 9. Which means 9 cannot be here, therefore this must be 9. This can't be 9, so 9 is one of these two. 9 is also one of these three. This can't be 8, obviously. 8 is one of these 4. This can't be 7, so this can't be 1. Can't be 2, so this can't be 6. This can't be 8 or 9. So it has to be 7 at most. 7, 6, 5, 4, 3. 1, 2, 3, 4, 5, 6. So this can't be 2. Ah. Where is 8? 8 can't be here. 8 can't be here. This has to be 8. Because this can no longer be 8. Therefore, this can't be 8 here. The 8 has to be one of these two. Let's see. Ah, this can't be 2 and 4. If this is 2 and 4, this becomes 7. But then this would have to be 1, 7. So this cannot be 2 and 4. So therefore, this can't be 6. This still could be 2 and 3. So it's either 2, 3, and this becomes 5. We have 1, 7, and this is 4. It could be 2, 5, in which case... So it's 2, 3, 2, 5, or 3, 4. Right, that's fun. Because we know the other 3 or 5 has to be here. If it's 3 and 4, this is 5. This becomes 2 or 7. This is 1. Yeah, so, If this is 5, this has to be 1, 4. If it's 7, it's 2 or 3 with 4 or 5. So this can't be green. Doesn't really tell us very much, but... Let's see. Hmm. 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 So whatever it is, the 5 has to be here, right? If this is 5, this is 2. Actually, that's not true. This could be 7 and 3, 4. That's not true. 8. Hmm. I mean, I feel like this is essentially the hard part is done, but this still feels pretty difficult, I will say. Um, huh. Let's see. Nine is one of those two. So if this is nine, this is eight and one. Hmm. Which means that can't be six. Sorry, that can't be three. Ah, okay. If this is eight, so okay. If this is nine, this has to be eight and one. So this cannot be three or for one, two. It can't be four. If this is nine, if this is eight, it can't be one seven. So it's two six or three five, which means this can't be three either. So either way, this can't be three. We don't know about four though. It still could potentially be four. One, three, two, six, eight. Right? Um, this can't be two, eight, or nine. So this is one, three, four, five, six, seven. Um, hmm. Hmm. So one can never be here. One could be here. Hmm. Hmm. If this is 9, this has to be 8 and 1. If this is 8, this is either 2, 6, or 3, 5. Oh, okay. So, if this is 8 and 1, that becomes 3 and 2, and therefore there cannot be a 2 and 3 in the rest of column 2, or row 2. If this is 2, 6, or 3, 5, that means this is 1, this is 1. There can't be a 1, 2, or 3, I guess. So the 1, 2, or 3 has to be here, here, or here, no matter what, right? Because if this is 8, if this is 9, this becomes 8, 1. This has to be 8, 1. And therefore that's 2 and 3. So there cannot be a 2, 1, 2, or 3 in the rest of row 2. If this is 9, this is either 2, 6, or it's 3. Sorry, if this is 8, this is either 2, 6, or 3, 5. Which means it's one. We have one. If it's 2, 6, this becomes 1, and this is 3. Which means 2, 1, 2, and 3 can't be in the rest of row 1 and row 2. And if this is 3, 5, this becomes 1, and that's 2. Which means the rest of row 1 and 2 cannot contain 1, 2, or 3. Therefore, this cannot contain 1, 2, or 3. This is 4, 5, or 6. This can't be 4 then. This can't be 6. Interesting. So then this cannot be 1, 2, or 3. This is 4, 5, 6, no 7, no 8, 9. This can't be 1, 2, or 3, or 7. So this is 4, 5, 6, no 7, no 8, and no 9. So this must contain a 4, 5, or 6. So therefore, this cannot be 4, 5. right? Because if it's 4 and 5, that means it would have to add up to at least 9. Therefore, it could be 3, 4, and that's 7. This is 1 or 3. This is 1, 3. We have a 1, 3, 1, 3 pair in row 3. So the rest of the row cannot contain a 1 or a 3. So this is, and there's no 2 also. So this is 4, 5, 6, 7, 8, 9. This is 4, 5, 6, 7. It can't be 8. So this is 4, 5, 6, 7, 9. 4, 5, 6, 7, 9. 4, 5, 6. This can't be 9. Therefore, we know the 3 has to be one of these two. So 3 is one of those two. This could be 5, in which case it's 1, 4. It could be 7. Okay, so this cannot be... If this is 7, this is 3, 4, or it's 1, 6. So this can never be 5 here. Can never be 5. The 3 has to be here. The 1 of 1 or 2 is here. The 3 has to be here, and 1 of 1 or 2 is here. Since only 1 of 1 or 2 is here, where is the other 1 or 2? It has to be here. That's 1, 2, or 3. That's 1 or 3. Yeah, that doesn't help much. Hmm. Okay, whatever's here must be the same as this. So this is the same as this one. The yellow must be one of these 3. We don't know about these, though, in these boxes. Pink obviously is one of those 3. Hmm. Ah, if this is 5, this has to be 4, and that's 9. So this can't be 9, so therefore this would be 9, this would be 4 and 1. But then this would have to be 8, and then this would have to be 1, and we have a contradiction. So it cannot be 5. This has to be 7, which means this can't be 7. Um, so therefore this can't be 7, therefore one of these 3 is 7. Hmm. If this is 8, 1, this has to be 3, 4. This can't be 7, therefore the 7 has to be one of these two, because the 7 can no longer be here. This can't be 7 then. These can't be 7, so the 7 is one of these 3, but that's not that helpful. If this is 1, 6, this has to be 8, and this is 3, 5. So that seems fine. If this is 1, 6, this cannot be 8, 1 anymore. So this is 8, and this is 3, 5. So 1, 6. If this is 1, 6, this can't be 8, 1 anymore. So this has to be 8. This is 9. This is 4, 5. So 1, 6. That would mean this can't be 8, 1. So this is 8. This can't be 2, 6. So this is 3, 5. Let's go through the scenarios then. If this is 1, 6, this can't be 8, 1. So this is 8. Which mean, and it can't be 2, 6, so this is 3, 5. So this cannot be, cannot be 5 or 6. It has to be 4. Which means this is 9 and this is 2. Okay, seems fine. If this is 3, 4, this can no longer be 3, 5. Either way, the 2 cannot be in any of this column. In those 6 cells. So the 2 has to be here. This can't be 2, obviously. So this cannot be 2. So therefore, this can't be 3, because you can't have 1 and 2 there. Hmm. Oh, interesting. So if this is not 1, so let's say this is 3, 4. This has to be 1 and 2, which means this is 3, 4. Which means this has to be 7. So then this would be 2, this would be 7. This would have to be 1. This would be 4. This cannot be 3. Therefore, this can't be 2, 3. So this would be 5, 6, 8, 9. Obviously can't be 6 or 8. So this would be 5 or 9. This can't be 3. Okay, so the other scenario was this was 8. This was 8, and this was 3, 5, 3, 5. Now this scenario is, this is 8 or 9. This can't be 3 anymore. It could be 5 or 6. So then this would be 1. It cannot be 5 or 6. It would have to be 6 and 2. This would have to be 1. This is 2 possibility there, so this would be, so for 1, 6. I see. So we know 2's here. This, if this is 1, 6, this has to be, this cannot be 9, so this has to be 9. This has to be 8, so therefore this is 3, 5. 3, 5, right? Therefore this is 2. This would have to be 4. So if this is 2, this is 7, which means this can't be 7, and this is 7. So that's if this is 1, 6. So if this is 1, 6, this becomes 8, this becomes 3, 5. This has to be a 9, 2 has to be in one of these. This can't be 2, so therefore this is 2. This would be then 7, this would be 2, so the 7 could not be here, and the 7 would have to be here. If this is 3 and 4, 1 and 2 have to be here, which means this has to be at minimum 3 plus 4, which means this is 7. So this is 7 either way. So this can't be 7. This is a 2. This is a 7. This can't have a 2. This can't be 2. So it's either 1, 6 or it's 3, 4. So this is 1 or 4. This is 1 or 4. There cannot be a 1 or 4 in the rest of the column. We also tried if this is, yeah. If this is 1, if this is 3, 4, this becomes 1, 1 over here because this can no longer be 1. Therefore, this is 3 and 4 in that scenario. And therefore, this would have to be 5, 6, or 9, 8, or 9. It cannot be 5. So this has to be 5, 9, which means this. So if this is 9, this could be 8 and 1. So if this is 3, 4, this could be 8, 1, 9. This is 3, 4. This is 1. Or this is 2, 6, right? And then this. So this we know has to always be 5 or 9, right? Because we tried the 1, 6 scenario. If it's 1, 6, this can't be 8, 1. So this can't be 9. So therefore, this must be the 9. If it's not 1, 6, it's 3, 4. That means this is 1, which means this is at minimum 3, 4, which means this is 7. So this has to be 1. There's no 3, so it's 5 or 6. So therefore, the rest of the column is 5, 6, 8, or 9. But you can't have a 6 or 8. So therefore, this cannot be 5. This has to be 5 or 9, which means 4 has to be here. So this can't be 4. You cannot have a 5 or 9 in the rest of the column, a row, in row 1. Because you have a 4, 5, 9 triplet. Therefore, this can't be 9. This has to be 1, 2, or 3. This is 1, 2, or 3. And this is 1 or 2. This could still be 4, 5, or 6. Actually, it would have to be 4 or 5, I believe. Can it ever be 6 is the question, right? If it's 6, this would be 3, 4. And this would have to be 9. It could be 9, 8, 1. And this would be 5 and 2. So, okay, that could be 6. So this is 1 through 6. This is 1 or 4. So and this is 1 or 4. So there cannot be 1 or 4 in the rest of the column. This can't be 2. So this can't be 6. This can't be 2. So the 4 is one of those two. Uh... Interesting. Okay. If this is 5 and 6, this would have to be 1 and 3, which would make this 2 and 6. I guess then 3 and 4 then, and that's 5, and that's 7. So that does work. Okay. So if this is 5, this would have to be 9, 8. This would be 6, 3, 4. This would be 1, 2, 3, and 4, and that would be 6. So far it's looking okay. This would have to be 1. Ah, that's the contradiction. Because this can't be 6, this would have to be 7 and 1. So that's the contradiction. So this one cannot be 5 then. So this has to be 9. Which means this is a 4, 5 pair. So this can't be yellow. This can't be 5. This can't be 5. So therefore it's 8 and 9. This can't be 9. Therefore this is 8. So this is 8. This is 9. This is 9. This is 8 just from Sudoku. This can't be 8 anymore. So this can't be 1. So it's 2, 6, or 3, 5. Does that make sense? Let me double check that. Well, okay, yeah, we were making this 9, right? So if this is 9, this is 5. This has to be 8 and 1, which means this is 3 and 4, and this is the 5. This is 6, which makes this 7 and that 1, which is impossible. So that, yeah, that doesn't work. So this cannot be 9. Therefore, this is 8. This is 9. Cannot be 8. And cannot be 1. So it's 2, 6, or 3, 5. This could be still 4, 5, 6. This can't be 2. This can't be 6 then. This can't be 9. So this can't be 5. So these can't be the yellow. This can't be 8, so this is 9, which makes this 8. This can't be 9, so this is 9. So no 9. This is 5 or 6. This is 4 or 6. This is 4, 5, or 6. That's fine. If this is 1, 6, this has to be 3, 5, and therefore this is 4. If this is 3, 4, this must be 2, 6, and therefore this has to be 5. So the 6 has to be one of those two. This can never be 6. Right? If it's 1, 6, obviously 6 is there. If it's not, if it's 3, 4, this has to be 2, 6. So the 6 is either one of those two. This can't be 2. Man, still complex. Jesus. So this is 1 through 7. Obviously, this can't be 2. This can't be 7. So therefore, the 7's here. This can't be 7. Oh, shoot, no. One of those 3 could be 7. If this is 5, this has to be 1 and 4, and this is 2 and 3, which makes these 3 digits 4, 5, and 6, 4, 5, 6, or 7. But we already have 2 digits, 2 cells that require 4, 5, 6, and 7. Therefore, this doesn't work. Therefore, this cannot be 5. So this has to be 7, which means this can't be 7, and this can't be 7. So this is either 2, 5, or it's 3, 4. This cannot be 1, so it's 2, 5, or 3, 4. So the 2 and 3 cannot be here. So this is 1, 4, 5, 6, and 1 has to be here. So this can't be 1. This can't be 2 and 3 are here. 2 and 3 has to be here. So in column 7 and 8, we have all the 3's. Therefore, 3 cannot be in column 7 and 8. Therefore, this is not a 3, and this is a 3. That's 3 in the corner. This is 1, 4, 5, 6. This yellow cannot be here because it corresponds to this 2 or 3, and therefore would not correspond to this 2 or 3. So this is 3 or 5, right? This is 6, so this can never be 6. It can never be 6. 2 can't be here, 2 can't be here, so therefore, where's a 2? It has to be here. So this can't be 2. This is 4 or 7. This is 2 or 4. This is 2 or 7. That all works. This can't be 7, therefore this is 4. This is 7, which makes this 6 and 2, which makes this 1, this 2. This can't be 2, so this is now 3 and 5, which makes this 4, and this 6 and 1. If this is 1, this would have to be 6, but what would be 6 with? It can't be with anything. Same thing here. If this is 6, where's the 1? The 1 has to be here. So therefore, this has to be 1 and 6. This is 1. This is 4. This can't be 6, so it's 3 or 5. This can't be 6, so therefore this is 6. This can't be 1, 4, 6, so it's 3 or 5. This is 2, 4, and 1 of 3 or 5. So there can't be 2 here. This can't be 6, so this is 1, this is 6. This can't be 2, so this is 3 and 4, which makes this 2. So this is 5, this is 3. This can't be 4 or 6, so this is 5, 4, 7. All the yellows become 5. All the pinks are 4. Well, we'll remove this pink. So therefore, these are 4. This can't be 3 anymore. This is 1. This is 3. This has to be an 8. This is a 9. This is an 8. This is a 9. This can't be 2 anymore, so therefore this is 2. This can't be 1, either of these. This can't be 4, so this has to be 1. This can't be 5 anymore, so therefore it's 3. This is 5, this is 3, this is 5. All of this is because of Sudoku. This can't be 3, this can't be 3, this can't be 5, so this is a 4, this is a 5. This can't be 4 or 5, so this is a 6. This can't be 5 or 6. This can't be 7, so this is a 4. This is a 7, which makes this a 3 and 4, which makes that a 1 and a 3. Not 6, 1 and a 3. This can't be 1, so it's 6. This is a 1. Therefore, that makes this 6 and this 5. And that's the solution. Wow. 4.5 hours to solve this. That was crazy. But still some really cool logic there. I really like, especially at the start of this second video, I really enjoyed realizing what that was, what this connection here was. Because that was, wow. To be able to come up with that and to come up with that setting, pretty amazing. Pretty freaking amazing. Anyways, I hope you enjoyed both of these videos. Pretty crazy, long videos. And I did stick the landing this time. I didn't mess up at the very end, which is good. Anyways, I hope you enjoyed it, and I'll see you next time on Frank Puzzles. Take care.